Hello, welcome to my poster. I'm Masahiro Shinya from Hiroshima University, Japan. Variability is one of the most important features of human motor control. In the field of gait and posture, many researchers analyze the variance or standard deviation of parameters such as step length, step width, and step duration. These gait variability measures are useful in both basic and clinical studies. The question we addressed in this study was, as the poster title suggests, how many trials and participants do we need to investigate gait variability? When we perform a priori power analysis, we assume the effect size. The key point here is that the denominator of the effect size is inter-subject variability, which depends on the number of trials used to calculate the gait variability. The larger the number of trials or steps, the larger the effect size, then the small number of participants are required. Therefore, we should plan both the number of trials and the number of participants to ensure statistical power. As a specific case, let's consider a research in which we compare variance between groups of subjects. An example of such study is comparing gait variability between fallers and non-fallers. We performed numerical simulations, as described here, to determine the recommended number of trials and participants. The result is shown in this heat map. If you want to detect a 1.2 times difference in variance between two groups with a statistical power of 0.8, it would be good to have 12 participants in each group and measure 100 trials for each participant, shown in this dot in this heat map. Alternatively, a research design where we measure 20 trials from 55 participants would yield a comparable statistical power. We also performed for studies with within-subject comparisons, such as comparing gait variability between pre-training and post-training sessions. Although the statistical procedure is a bit complex, as described here, the recommended numbers of trials and participants are pretty much the same as for the between groups comparison studies that I've just explained. The details shown in this table. In conclusion, our simulations shows an inverse relationship between recommended numbers of trials and numbers of participants to ensure the expected statistical power to detect differences in gait variability. I hope this kind of simulation contributes to solid research design. Finally, you are very welcome to download my poster and share it on social media, such as Twitter. Feel free to contact me via email or the conference app to ask me any questions or comments, or request a MATLAB code for the simulation. Thank you very much for visiting my poster. Enjoy the conference.